Okay, guys, we're going to do 7.3 today, part 1, part 2 tomorrow, and then we're going to review for our quiz, take a quiz on Thursday. We're 7.1, 7.3. All right, you are going to have on your quiz word problems. You're going to have to put stuff together. I will show you in a minute on modules. If you guys go to modules, in your notes, I put 7.1 word problem example because some people were emailing me having questions about the word problem in 7.1. So I just worked a couple of them out so you guys could see how to find the perimeter, which we should have been able to do. Today's lesson is not at all difficult. You guys will be perfectly fine. It's just kind of long. 7.3 talks about multivariable linear systems, okay? Multivariable means more than one, right? Linear, everything's to the first power. And it's a system, meaning there's more than one equation. So if you guys look here, this is a system of 3 linear equations with 3 variables. Do you see how all of the x's are lined up on top of each other? All of the y's are lined up on top of each other. All of the z's. And then you have an equal sign and numbers. Everybody see that? Yes? You're with me? Okay, you're going to learn at the end of this lesson how to solve this exactly like it is. It's not, like I said, it's not difficult. Some of you are going to say, oh, I remember doing this last year. I had some people in A period said the same thing. But it's a little bit of a process. This is when you have, this is the equivalent system. This is the same thing. Equivalent means the same. This is in row echelon form. Okay, if I gave you these sets of equations exactly like it is, everybody in here could solve this. How would you figure out what y and x are? If you're looking at the equations in row echelon form, what would you do?
Plug in the z.
Plug z into the second one, right? Find y, and then plug y and z into the top one to find x. That's called back substitution. That's also called common sense, which is what all of you have, so that's great. When you answer these questions, you have an ordered triple, right? When you had a system of equations with 2 variables, we had an ordered pair, right? So now we have an ordered triple. You have an x value, a y value, and a z. Is it important that you put the ordered triple in a specific order? Yes, you can't just randomly have 3 numbers. You have the first spot is for the x, the second is for the y, the third is the z. If you have an additional letter, it might be a w, so it goes in alphabetical order, however you need to. So if you have a problem like this, like we just said, we're going to use back substitution. I'm going to take my z value. I'm going to plug it in right there to find y. So y plus 4 times 2 equals 7. Y plus 8 equals 7. Subtract 8 from both sides, and y equals what? -1. Good. So now I know what y and z are. I'm going to plug those 2 back into the top equation to find x. X minus 2 times -1 plus 3 times 2 equals 9. Agreed? So I have x plus 2 plus 6 equals 9. X plus 8 equals 9. Minus 8 from both sides. And what does x equal? 1. So I would write my answer as an ordered triple. You don't just leave it like that. You write it as an ordered triple. So my ordered triple would be 1, comma, -1, comma, 2. Questions? Yes or no? What should I do with 1, -1, and 2 just to make sure that I'm right? Plug it back in. Just plug it back into the top one. Make sure. All right. So if you are given a set of equations and then they give you an ordered triple and they say, is this a solution or not? You just plug back in, right? Like in a case like this, it says show that the ordered triple 1, 0, and 2 is a solution for the system. So what you would do to show is you would say, okay, in this first equation, I have 1 minus 3 times 0 plus 2 equals 3. So -3 times 0 crosses out, right? 1 plus 2 is 3. Does that work? Yes. So now I go here and I say, okay, 2 times 1 plus 0 minus 5 times 2 equals -8. Well, I have 0 here. What is 2 minus 10? Okay, that one works there. So then I have 1 minus 0 plus 3 times 2 equals 7. What's 1 plus 6? 7? All right, so this works. If you get a question that says, is this order triple a solution? And you plug it back in and it works in 2 out of the 3 equations. Is that a solution for all 3 of them? No. So just make sure that if they ask you if it's a solution, plug it into all 3 and make sure it makes all 3 true. I need to see that on your web assignment in order to get credit for stuff. All right, so back substitution. Let's go through this quickly so we can get to the next part. I know that z is 8, so I'm going to take 8 and plug it into my second equation. So y plus 2 times 8 equals 6. Y plus 16 equals 6. Minus 16 from both sides. What does y equal? Negative 10. Good. So now I take those 2 and I plug it into the top one to find out what x equals. So 2x minus negative 10 plus 5 times 8 equals 24. This is very basic, very simple, but if you skip a step, if you miss a negative sign, something like that, it throws everything off. So just take your time. Here I have minus the negative, so I have 2x, 10 plus 40 gives me plus 50 equals 24. Minus 50 from both sides, you get 2x equals negative 26, yeah? Divide by 2, what does x equal? Negative 13. And then I write my ordered triple. So my answer would be negative 13, negative 10, 8. Correct? You guys with me? What do I do to make sure that I'm right? I would take all 3 of those and plug it into the top equation. Just make sure it makes your equation true. Questions? Okay, now we're going to do something that is a tad more complicated. We are going to manipulate these equations so we get them into row echelon form and then can use back substitution to solve. All right, I'm going to go through this with you, and once we do a couple of them, you guys will be like, oh, okay, we're good. But you're going to pick 2 of the 3 equations and cancel out a variable. That becomes your new number 1. Then you're going to cancel out another thing, and it becomes your new number 2, and then you're going to have your number 3. That's what all of this says. Let me go through it with you, and you'll see. There's some rules, though. Let's write down some things that are very important. Your first equation must begin with a positive 1 coefficient of x. If it doesn't, you need to do something to get it to be positive 1. All right, let's just say that this was like this. Right? The rule is you have to get the first equation to be a positive 1x. Well, none of these are positive 1x, so what would I do? Okay, I can times one whole equation by negative. What does that do? It changes all the signs, right? Perfect, good. What about, right, we have to start with positive 1. So say this is 4, say this is 2, and this is 6, and this is 18. What could I do? Is there anything I could do so I could somehow get one of the equations to start off with a positive 1x?
Divide by 2.
Divide everything in the first equation by 2, right? I will always give you something that you can manipulate to make sure that one of the equations starts off with positive 1x. Whether it's dividing by a negative, multiplying by a negative, however you want to look at it, dividing by a number to get the GCF out, something like that. But we will always be able to do that. So we are going to be able to find out what x, y, and z equal by going from this form to our row echelon. So what we're going to do is the first thing, you guys are going to set up your equations over here. So rewrite the first equation. X minus 2y plus 3z equals 9. I was telling first period, last year I remember working on one of these problems and it took me like 20 minutes. I could not figure out where I kept going wrong and I copied the problem wrong. I forgot a negative sign. That will drive you insane. And it's going to happen to some of you. So just make sure you're just taking your time and rechecking. All right, but the way that we do this, the first thing, okay, we wrote our first equation. I have an x and a y and a z. My second equation should have just a y and a z, and the third equation should say just z. So the way that we do that is you take the first and second equations, right? I'm going to take 1 and 2, and I'm going to eliminate the x's. So x minus 2y plus 3z equals 9, and negative x plus 3y plus z equals negative 2. Is this already set up to where the x's will eliminate each other? Yeah, right? I don't have to multiply anything. I already have exact opposite coefficients of x. So just add down. This crosses out. Negative 2y and a positive 3y is 1y, right? 3z plus 1 is 4z equals 9 minus 2 is 7. All right, there's our second equation. Y plus 4z equals 7. Questions? All right, now my last equation up here should say z equals. So the way that we do that is we're going to take the first and the third and eliminate x's. So I have x minus 2y plus 3z equals 9. And then I have 2x minus 5y plus 5z equals 17. We good? All right, what do I have to multiply the top equation by so I can get my x's to cancel out? Negative 2. Agreed. Now, guys, watch what I do. Negative 2 through the entire equation to both sides of the equal sign. A lot of times we forget to do the constant. So if you need to draw yourself a little picture, do that. So I have negative 2x plus 4y minus 6z equals negative 18. Correct? All right, that top equation's gone. Now we combine. What happens to my x's? They cancel. Negative 5 plus 4 is negative y. 5 minus 6 gives me negative z equals 17 minus 18 is negative 1. Agreed? Now, I have my first equation that has x, y, and z. I have my second equation that has y and z. Now I need my equation to be just z. What do you think I do from this point? Anybody have an idea? I'm going to take these two and do what with them? I'm going to combine them. Hi. So we're going to take my resulting here, y plus 4z equals 7, and my resulting from the other one, negative y minus z equals negative 1, and combine to get your y's to cancel out. So we take 1 and 2, eliminate x's. We take 1 and 3, eliminate x's. Then we take those two, eliminate y's. This is already set up to where we can do that. What's y minus y? Cancels out, right? What's 4z minus 1z? 3z equals, what's 7 minus 1? 6. Divide both sides by 3. What does z equal? 2. So I write right here, z equals 2. Have we solved this equation? Or this systems of equations? No. But do I have a setup now in row echelon form where I can very easily find the ordered triple? Yes. We're going to take the z and do what? What am I going to do with z? Plug it in to the second equation. So y plus 4 times 2 equals 7. Y plus 8 equals 7. So y equals what? Negative 1. All right, so I know what z equals. I know what y equals. Let's find out what x equals. So x minus 2 times negative 1 plus 3 times 2 equals 9. X plus 2 plus 6 equals 9. X plus 8 equals 9. So x equals what? 1. So my ordered triple is 1, negative 1, 2. This answer to this question is 2 parts. Part 1 is putting your equations into row echelon form. And then part 2 is your ordered triple. This is a long question. We can't give you like 10 of these on a quiz. I understand that. But it's very, very doable. You just have to first make sure that your first equation is set up to where x is a positive 1 coefficient, and then just go from there. The more you practice this, the easier it gets. Like, look at this one. What's the first rule? What's rule number 1?
Has to be
Positive 1x has to be the first equation. Is it? No. Can I just switch the first and the second, though?
Yeah.
Yeah, absolutely. We can do that. So I'm just going to rewrite this as x minus 2y plus z equals 8. And then it doesn't matter what goes next, either the 4x, negative 4x or 2x. I'm just going to switch spots. So it's 2x plus y plus 3z equals 9, right? And then negative 4x plus 3y plus 2z equals negative 4. So again, I'm going to start off with my first equation is x minus 2y plus z equals 8. Okay, my second equation up here in my little bracket here should say y and z. So I'm going to take first and second, x minus 2y plus z equals 8, and 2x plus y plus 3z equals 9. And what am I going to do? Eliminate what letter? Let's eliminate always x's. We're going to eliminate x's. So what are you going to multiply the top equation by so the x's will cancel out? Negative 2 again, okay? So all the way through to everything on both sides. So I have negative 2x plus 4y minus 2z equals negative 16. Agreed? So now my x's will cancel. What's 1y plus 4y? 5y, good. What's 3 minus 2? So just 1z equals negative 7. Okay, good. So my second equation is 5y. Is it plus or minus? Plus z equals negative 7. So now I'm going to take the first and the third. So x minus 2y plus z equals 8. Negative 4x plus 3y plus 2z equals negative 4. What am I going to multiply the top equation by? Positive 4. Good. Whole way through. So 4x minus 8y plus 4z equals 32. Agreed? Okay. What happens to my x's? They cancel. 3y minus 8y is negative 5y. 2z's and 4z's gives me 6z. And negative 4 and 32? 28. All right. My last equation, I have one equation that has 3 variables. I have one equation that has 2. Now I need an equation that just says z equals. So what do I do with the yellow and the red? I'm going to combine them, right? Does it matter which one I put on top of each other? No. So negative 5y plus 6z equals 28. 5y plus z equals negative 7. And it already works out nice and pretty. I don't have to do anything other than combine. Negative 5y, positive 5y, gone. 6z plus 1z, 7z. 28 minus 7. Divide both sides by 7. And z equals 3. So I come back up here and I say, okay, z equals 3. Have we solved this system of equations? No. Can we though, real quick? Yeah. I'm going to take my z and plug it into 5y plus 3 equals negative 7. If we subtract 3 from both sides, 5y equals negative 10. So y equals what? Negative 2. Good. So now I take my top equation, x minus 2 times negative 2 plus z is 3 equals what? 8. So x plus 4 plus 3 equals 8. X plus 7 equals 8. What's x equal? Yep. So write your ordered triple. What's your answer? 1, negative 2, positive 3. Is there a big difference, guys, between negative 2 and positive 2? Is it that big of a deal? Yeah, it's a huge deal. So make sure, just go back, take 2 seconds. You don't have to write out a check. I don't have to see you plug everything in. But go back and just make sure you plug in 1, -2, and 3 for x, y, and z. And it all comes out nice and pretty. Okay, let's do this one. Are we already set up?
Yeah.
Okay. So our first step is to rewrite the first one, right? X plus y plus 3z equals 7. Agreed? Okay, so I'm going to take 1 and 2. X plus y plus 3z equals 7. And 2 is 2x minus 4y plus z equals 7. What am I going to multiply the top by? So my x's will cancel out. -2. Agreed. All the way through. So I have -2x minus 2y minus 6z equals -14. X's cancel. What's -4, -2? -6y, okay. +1 minus 6 minus 5z equals -7. Okay. So -6y minus 5z equals -7. So now we're going to take 1 and 3. X plus y plus 3z equals 7. 3x plus 5y minus 4z equals -6. What am I going to multiply the top by? -3, okay. So -3x minus 3y minus 9z, right, equals -21. Agreed? Okay. What happens with my x's? Cancel. 5y minus 3y is 2y. -4 and -9 is -13z. And what's a -6 and -21? -27? Okay. Now what do I do with the green and the yellow? I'm going to combine them. Right, one on top of the other. So I'm just going to say, okay, 2y minus 13z equals -27. And -6y minus 5z equals -7. What am I going to multiply the top by? Just +3? Okay, all the way through. So I have 3 times 2 is 6y. 3 times -13, -39z. And then what's 27 times 3? 81? Minus 81. All right. Now let's combine. What happens with my y's? They cancel. Okay, what's -5 and a -39? -44. Z equals, what is -7 and -81? -88. All right, now what happens? Divide both sides by -44. And z equals what? 2. So z equals 2. Question. So here is our row echelon. Have we solved this? No, we have not solved this, and that's okay, because now we can. I know that z is 2, so I'm going to say -6y minus 5 times 2 equals -7. So -6y minus 10 equals -7. Add 10 to both sides, right? -6y equals what? 3? Yes? Divide both sides by -6. And what does y equal? -1/2. Please don't put 2. All right, I got a fractional answer. No big deal. So now I take -1/2 and I take 2 and I plug it into the top. So I have x plus y is -1/2 plus 3 times 2, right, equals 7. You guys with me? Yeah? Okay, so I have x. What is 6 minus 1/2? This is 6, correct?
Yeah.
So if I make it into halves, this is 12 over 2. So this gives me plus 11 over 2 equals 7. Can I change 7 into halves? Is that okay with you guys? If I change this into 14 over 2? Go with me? Okay, so subtract 11 over 2 minus 11 over 2. And x equals what? 3 over 2. So in this case, my ordered triple has some fractions in it, but that's okay. No big deal. My x is 3 over 2. My y is negative 1 over 2. And z is positive 2. And we can take just a little bit of time, and we can go back and check that, can we not? If I have my top equation, x is 3 over 2, and y is negative 1/2. Well, 3 over 2 minus 1 over 2 just gives me 2 over 2, which is 1, right? And then 3 times 2 is 6. 6 plus 1 is 7. We're good. In the second equation, I'm going to say 2 times 3 over 2 gives me what? 6 over 2, which is 3, minus a negative 1/2 times 4, which is going to be plus 2. And then plus 2 gives me 7. And we plug it in the bottom one, and it works. Again, you guys are going to have calculators. We need to be able to use fractions. You need to be able to work with fractions. But you will not have a fraction in your original equations. That's important for you guys to know. All right, let's do the last one real quick, and then we're done. This can happen sometimes, so I just want you guys to be aware. First of all, if you notice, 2 of these have a positive 1x coefficient, correct? If for some reason you wanted to move the bottom one to the top and the top one to the bottom, that's fine. But I would just leave it. So I'm going to rewrite, okay, my first equation is x minus 3y plus z equals 1. So now I'm going to take 1 and 2 and eliminate x's. So x minus 3y plus z equals 1. 2x minus y minus 2z equals 2. What am I going to multiply the top equation by to get the x's to cancel out? Negative 2. Good. Negative 2 all the way through. So negative 2x plus 6y minus 2z equals negative 2. Agreed? Okay. X's cancel. I have 5y minus 4z equals 0. Is that an okay equation? Absolutely. I needed a y and a z, and I'd have that. So I have 5y minus 4z equals 0. So now I take 1 and 3, and I eliminate x's. So x minus 3y plus z equals 1. X plus 2y minus 3z equals negative 1. What do I have to multiply the top by? Negative 1. Can I just go through and change the signs? You guys okay with that? So if I change this minus, plus, minus, minus. Okay, what happens to my x's? They cancel. What's 3y plus 2y? 5y. Minus 4z equals negative 2. We good? All right, so now I take these two and I combine them. 5y minus 4z equals 0. 5y minus 4z equals negative 2. What do I multiply one of them by? Negative? I'll do the bottom one. So minus, plus, plus. What happens to my y's? They cancel, so it's 0. What happens to my z's? They cancel. And then what does this equal? First of all, does 0 ever equal 2? No. But when we're writing in our row echelon form, my first equation should have 3 variables, the second one should have 2, and the last one should have 1. Do I have any variables left here? Yes or no? No. So my answer here, guys, would just be no solution. That doesn't happen a lot, but it can, so I just want you guys to see that. This stuff is not ridiculously hard. It's just long, and it can be tedious. You have to really pay attention to what you're doing. So you just need to practice. The more you practice this, the quicker you'll be able to get through it, so it's not as daunting. Sound good? Tomorrow we're gonna do part 2. You can get most of your WebAssign done. Your WebAssign's not done. WebAssign is not due until Wednesday. You can get most of it done today. I think it's 14 questions, and I think 12 of the 14 you guys can do now. But I will upload this video so you can go back and watch it, and then we'll finish up tomorrow.